part of the basis for this workshop is not so much to train everyone on how to data science with Python. I'm not aiming to create any of you into fully blown professional career programmers. And instead, I want to instill the idea that Python and other programming languages, if anything, Python's my weakest programming language, but they're tools for all of us to use, not just heavy career-oriented individuals. So that's my aim for this workshop, is just to get you started. You're not going to know Python at the end of this, but you will know a little bit about how to go about using it. Which is very useful. And that's where the notebooks come in. Those are great because you don't need to have a huge infrastructure and you can just use it as a calculator. Speaking of notebooks, the email went out, I believe yesterday, and I learned something about Dropbox. They have this new feature called transfer. You want to transfer a bunch of stuff to somebody else, you can do that. And it's not like sharing it where edits propagate. They don't. Once you make a transfer, it's like making a zip file and sending it to them. They were just getting it from Dropbox instead of from the email. So I made the transfer and I sent it all out. And then, of course, I made edits, right? And they don't update. So that had to change. If you see the chat, can you guys let me know in the chat if you're able to download it? This link should now work. This one here. No, this one, wait. I'm trying to get some action happening. There we go. That one there. Just pop a message in the chat. Are participants able to? Yes. Okay, good. Thanks. Excellent. Good, good, good. Let's have a quick show of hands. You can use the feedback tools. I never know where they are. I'm sure you'll find them. How many of you have never done any programming at all, or very, very minimal programming? Or you've forgotten it? Have you forgotten it? I suppose you can't answer that question in the... Helen, yes, raise your hand. I see your hand raised. Tick, yes, okay, so you have not done. Okay, okay, so it looks like then the bulk of you have had some experience with it, but I am going to start at the beginning, and I'm not going to linger on it too much, like I'm doing now. So, moving forward, how to data science with Python. Here's a thing as well. I showed this to first-year undergrads, just to encourage motivation. So use it for whatever you need. There are many studies about the connection between aptitude and ability when it comes to doing, aptitude and success when it comes to learning programming. This is a bit of an older study, 1999, and they found there was no connection between measured aptitudes. So they filled out a questionnaire, asked a bunch of questions, and then based on those results, compared the results of their at the end of their first year. And there's no correlation between what they said in the survey and their actual performance. So I like that because it tells me that anybody can learn this stuff, and it's not just people that started when they were 12. Okay. Instead, they concluded, and this is repeated over and over again, that intrinsic motivation and a growth mindset were the key factors in success. So you have to be, willing to learn, wanting to learn, and able to know that you can learn, and that will lead to some success. Anyway, there are other studies as well. I'm sure that you'll find studies out there that refute those points, but nevertheless, that's what we're going with. Okay, so Jupyter Notebook, which you should already have. Is it sure? Yeah, Amarav, the Dropbox link is, just scroll up in the chat, it's there. It ends in 49U, as in uniform. Let me know if you have trouble. Thank you. Okay, so before we do any data science, we need to get a grip on the basics of the language. You need to know how to express yourself in Python. Bit of housekeeping for a second. There we go. Okay. So what are we going to do today? Well, we're going to do these things here. Okay. We're going to talk a little bit about the philosophy of why we should be doing programming in the first place. I think it's pretty clear to everybody, but we're going to cover it. We're going to look at handling small data. Glad to see you guys got the notebooks. That's great. That means how to deal with very basic syntax, how to use Python like a calculator, okay, before we go on to the more advanced stuff. And then how to not repeat yourself, how to use iteration. We've all heard of the expression, oh, just use a for loop. In Python, we don't really use for loops in quite the same way. The way the language is written is more expressive than that. So we'll cover that. And then we'll start handling large data. We'll import big data files and start to inspect them and have a look. We're gonna have a quick break, then talk about libraries, then talk about visualizing prevalence. So showing things on a map. And that'll be enough, I think. Now, this is intended to be an interactive session. So I've just encoded that here quickly. You can see I'm going to talk for a little while. I'm doing it now. Then I'm going to talk for a bit. Then we're moving on to the notebooks. Okay, the 2 equal signs indicates you guys are going to be doing some of the coding and chatting, and we'll work together as if we're actually in a workshop. We'll try it out. Okay, then we'll have a break, during which you are free to go grab some food or a drink, or you can stick around and continue on the practice problems that you won't have time to finish. Okay, so we're going to use that block of time for that. I'll be present during most of it. We're going to move on from that, handling large data. Again, I think this list is kind of not in order. So I'm not sure what's going on exactly. Let's call it a bug. Okay, and then at the end of it, we're going to wrap up with visualizing prevalence. Gosh, my tongue today. I tell you what, it's early in the morning here, so you'll have to forgive my speaking tics. All right, moving on. I want to talk about reading code. Now I'm going to bring back that same graphic I showed you before. This time I've highlighted all the spaces. Okay, this is a key concept. Most of you already know this, but for the very few that may not, I want to just focus on it. There's 2 features I want to show you. First of all, the peculiar font. You would not want to read a paper in this font. It's really hard to read, okay? But it's very useful for coding because of the shapes of certain letters. That there represents the number 0 as opposed to this one, which is the capital letter O. Now in Arial and Helvetica, 0 and capital O are basically the same shape. You can't tell them apart. Likewise, so is L and 1. So by design, we use a programming font that very clearly highlights the differences, and it's unambiguous. That is in no way a 1, and this is in no way an L. Okay, that's the first point. The second point is that this font is monospaced, meaning that every single letter, whether it's the letter I or it's the letter M, there they are together, take up exactly the same space as each other, and so do the spaces. Okay, and that means that you can use spacing, a bit like ASCII art, to align things in columns. Okay, and that's why our little segments here, oh my goodness, I have not actually gone over yet. That's amazing. Awesome. Well, these little line segments here, these little vertical bars, they line up. Okay, and I know that's pretty for ASCII art, we want it, but it's also crucial to understand specifically for Python. Okay, because Python doesn't have bracket characters. Okay, you don't see, oops, you don't see these shapes. Okay, sorry, my penmanship is terrible. You don't see shapes like that wrapping things, like you don't have functions that are enclosed by curly braces. Okay, instead, what you have is indentation. Okay, so you can see that this, by the way, this code here is way more complicated than the stuff we're going to be dealing with. I just want to show you what a sample, here's a patient class. Okay, it's got an initializer, it's got some function or method inside that can return their age as a calculation. Okay, that's all useful class stuff. But everything here is indented by exactly 4 spaces. Okay, and if you were to outdent or indent this one more space, this wouldn't compile. Okay, you'll get an error. Okay, so this alignment is key. Okay, it's not just for pretty pictures. All right. So anyway, like I said, we're not going to be doing anything that simple, but we're not going to be having a complex code like this in the following examples. Okay, so that's that. I bet was kind of workshoppy. Any quick questions? Anyone have any hands raised or anything to? If you see me looking up, I've got a monitor above my monitor, so I'm not looking up at the ceiling. Okay, I don't see anything. Now, I know this is probably common knowledge to you guys, but it's worth spelling out, especially if you go on to teach others. You know, they may not notice that or know the ins and outs of it. So let's dive into a little bit of the philosophy behind all of this. And there's a concept in computer science that's taught very early on about layers of abstraction. Okay, and if we start at the top, you might say there's a problem. Okay, you know, we need a method for calculating BMI. You know, let's say on our database full of 5 million patients. How are we going to go about doing that? And we can discuss the problem. Here's, you know, we have a formula, we have the data, but the data is in imperial measure, it's not in metric. What are we going to do? Okay, and you can talk about that, and you can even solve the problem using words right up at the top. You don't need to know anything about algorithms, okay? But, you know, let's say you do try to implement it in machine language. You may have an algorithm that you need to write. So you might break down step by step how to go about it, okay? Which is fine. And you might do that regardless of what package you're going to use. You might do it in Excel, you might do it in SAS, maybe you're going to do it in some other package that I haven't mentioned here. But it doesn't matter if you're talking at this level of abstraction. Okay, you're still dealing with concepts in math. Okay, and then it comes down to the package itself. And to use Excel, you don't need to know anything about programming. And for programming, you don't need to know anything about the specific instruction set that your computer's CPU uses, in which case you don't need to know anything about the computer's CPU or how it's designed or what devices it has on it. None of that matters, yeah? But everything from programming down requires all of those things. Even if you don't understand it, you don't know how to do maintenance on your car, but you do know how to drive it, right? It's abstracted away so that you don't need to worry about it. Okay, now I've put this one in italics, package, software systems, okay, because this is where we tend to work. You know, we tend to solve problems immediately. Oh, we'll get an app, we'll figure the answer. Okay, now all I'm asking as a result of completing this workshop is that you gain an understanding of how to go one step below to a programming language, okay, where you can customize things and make better solutions to the problem, should it be needed. It won't always be needed to go down to the programming layer, but sometimes it would. Often you're just fine up at package, okay? But you'll see in a couple of examples, it breaks down pretty quickly, especially when big data gets involved. Okay, so for example, ever try loading 2 million rows of data into Excel? I don't know if you've tried. I don't think I have. You can't. Okay, Excel has a limit of just over 1 million rows of data and other limits. Okay, at the bottom, these are the references. Click them. You'll jump to the references section at the end of the document, and in there's usually the link that you need. Okay, so you can't do it. Okay, it's not possible. SAS, yeah, you can load 2 million rows in SAS. Details are here, but the author, Kroos, warns that you know, you're going to get slowdowns as soon as you start piling the data on. Okay, so why would we choose to program? Well, this is one very big reason. As soon as you have too much data, it doesn't fit into most packages. And so you may need to do some programming. And it doesn't mean you have to build a brand new app to do it. It just means you can get your hands dirty and do the calculations somewhat manually. But you'll see later on that really you're just putting components together. You don't have to code anything from scratch necessarily, at least not the low level stuff. Okay, lower level methods, skills, and toolkits allow us to handle large quantities of data at speed. Okay. Okay, without programming, the other thing is that you're limited to what the programmers allow you. And the clear limitation here is the 1 million row limit in Excel. You want to deal with 1,000,005 rows or 1,500,000 rows? You can't, you're limited, right? Without programming, you have those limits. But if you need a custom algorithm, sorry, I jumped ahead. If you need a custom algorithm, then fine. You're better off making your own. Okay, it is said that Python is beautiful. Not my words. They come from Raymond Hettinger. If you want to dive in a little deeper, go and check out this guy's talks. He's great when it comes to discussing Python. He's very passionate about it. definitely worth checking out. It's clear and uncluttered. It's idiomatic, and it doesn't mean we don't know where it came from. Idiomatic in this sense means that there are ways of expressing programming algorithmics in Python that are very different from other languages. It's much easier to write in Python than it is in other languages. It may not seem so at first, but once you get used to the syntax, you can express an idea very quickly in Python. So why Python? Because of all of this. It's actually easy to read in other languages because of the uncluttered approach. You will find that Python is easier to read than other languages. And I'm going to show you an example on that in a slide or two. And also, Python is not new. It's been around for a long time. I remember a long time ago, Python first came out. The handbook for it was a huge, like the size of a telephone book. Well, it still is, but you don't need to read the whole thing. The Python world on the internet is large and helpful. If you have problems that you need to solve, your first recourse is to Google them, and you'll often find out exactly what you need online. Try that with C++? Yeah, less so. Okay, so in Python, we have high-level abstraction. This is abstraction in a different sense, abstracting ideas. Here's the hello world program. We all know what this is. Print hello world, that line is hello world in Python. You don't need all the rest of the stuff. Putting that in a console or in your notebook and doing shift enter will spit out hello world, okay? But we can abstract that by declaring a function, which is what we did here. We declare a function and its only job is to print hello world. Great, every time you need a hello world, you just call this, okay? And it's pretty clear to understand. This is a bit of an obscure line. We don't need to worry about it for this course because we're going to be using the notebook. But when you're writing software modules, the line comes in and it prevents all the functions from running or any other code from running if you're opening this as a module in another package. Okay, so that's it. If you want to call hello world, you go for it that way. Compare it with what it looks like in assembler. Now, this is a bit of a gross example, okay? Assembler these are machine instructions. We think about our layers of abstraction if we go back in our minds to those slides. Here we're dealing with the chip, okay? The actual computer chip you have in your laptop or your PC or whatever you've got matters for assembler, okay? You need to use the correct assembler and the correct syntax for the correct chip, okay? Now, Python abstracts all of this. This code here on the left prints out hello world. It does exactly what this one does. Okay, and ultimately, when you run Python, it will compile to this, and then this will run. You don't care, it's abstracted away, okay, and all you need to worry about is this. So when I say that Python is easy to read, this is what I mean. This is not that difficult to understand. Print hello world, oh, I know what that does. Can you figure out what this does? Not really, not unless you know what you're doing in this, and we don't ever need to worry about that, okay? Abstraction is a key concept. So one more thing, just to nail the point home about Python. Let's say they come down from above and give you a job to do. We need to weigh koalas in a lab and test them for things, okay? So what are you gonna do? The Excel approach would be like this. You got a big Pyrex soup jug and you stuff the koala in. He doesn't look too impressed, does he? And you pack him with a blanket and zero that, I guess, and then weigh it on the scale. That's fine, it works. You know, you want to use Excel to do some complicated new thing that Excel doesn't normally do, you got to use what you're given, right? Okay, but I prefer the Pythonic approach and answers the question, well, there's got to be a better way, right? What's the better way? You would use Python and construct a thing like this. Imagine this is a piece of Python code that does exactly what you need, customized, and it's easy to understand. You bring the koala close to this thing, the koala will climb on for you. You don't have to stuff them in a cup. So why would you use Python? This is a good, you know, a bit cheeky summary as to why. All right, see how much happier he is? He likes Python. Okay, so why programming? Why Python? You get control over your abstraction. If you need to innovate, create visualizations, create things that are beyond the constraints of libraries or other packages, you're gonna have to roll your own or make your own. And that's what Python allows you to do. It's also fast. Python, once it compiles, can be almost as fast as C, the benchmark for speed in programming. Okay, but it's much easier to write than C. You would choose Python because Python's easy to read, it's easy to write. Okay, and again, we have an enthusiastic, friendly, large, global community out there at your fingertips. Okay, and there's never been a better time to learn a language like this. Let's move on to handling small data. Let's talk about syntax and expression. Okay, and we need to, because I can't dive in and show you stuff about how to use GeoPandas to render a map with colored splotches on it until you understand the basic syntax of it. Okay, so we're going to do a bit of that here. Okay, and we're going to use some raw data, and just to compute some values, something simple like BMI. This will be in, excuse me, in the first notebook. Okay, and we're going to take numerical values, which you can supply, or you can use the examples I've given you and compute stuff from that. Okay, now the key thing, this is the most fundamental of all the abstractions, and it's the concept of a variable. If you don't get this straight in your head, the rest of it becomes very difficult to understand. Okay, so let's say this orange cup represents the variable foo. Foo is just a name, you can call it whatever you like. Okay. Variables are places where you store things. Okay, you can store the string, a word in quotes is a string, it's called a string, into foo, and that's just fine, it loves it. Later on, you can say foo equals 1, 2, 3, 4, and store an integer in there. Variable really doesn't care what you put into it, and you can later replace that or start with an expression in curly braces, which is basically a list of other things, okay? And that can go in there as well. There's no predefined types. You don't say that foo is going to be a string and it's going to be hello and we're done, we're always a string. It doesn't work like that in Python. Think of variables as cups, okay? Just like you might put strawberries into a cup later on, take the strawberries out, put paper clips in instead, cup doesn't mind, right? Python variables do not care what they contain because they have no declarative type. Value you put in has a type. That's a string, that's an integer, that's a list, fine. But the variable itself has no type, okay? And it's great. You can put the word hello in the variable, or you can put 82 megabytes of data into the variable. The variable will accommodate, so long as your system has enough memory. Okay, so it's a basic container for to store your values. I can say foo equals 1872, boom, and recall foo. Foo will be 1872, it'll print it out for you. Later on, the very next line of code, you can replace it. Python lets you do that with some other value, even some other type, okay? So the key concept in a variable is that it has a value that varies over time. That's where the word variable comes from, okay? It varies over time, okay? And that's pretty well the key abstraction. If you want to store a year in there, it's much better to store it in a variable and use it in many places than it is to use the hard-coded value in many places. Okay, imagine you use 1872 all over your program, and someone comes up saying, actually, it's 1827. Okay, now you got to go edit all the places in your code where you put that number in. Okay, instead, if you assign it to a variable, all you do is edit that, you're done. Okay, so use variables whenever possible. Okay, first thing we're going to do is open the notebook, handling small data. That didn't go as planned. Okay, so just to reiterate, if you click that link, let's get back, you'll end up here, you click download, it downloads, you'll store it somewhere, it'll be on your desktop, unpack it, it's a zip file. Usually I have a platform, you double click it, and away you go. Here it is on my desktop. You'll need a command shell for this. If you already have Jupyter, don't redo it, you've already done it. It's not necessary. You're here, so you would cd into notebook. Okay, and have a quick list, and there's the first file we want that one. But all you got to do here, because you have Jupyter Lab installed, Jupyter Lab, you just run it on its own. You don't give it an argument and press enter. Okay, it's neat. It spawns up a server, it connects with Python, it opens up the web browser, it points the web browser to itself, localhost 8888, it's on its own special port, and it shows you all kinds of stats that you can just go ahead and ignore. You don't really need those. Okay, and you end up here. Turns out we're on the right one right away. That's probably because when I closed this, we ended up there. So there are other notebooks. There's more than one. This is a typical web app. It's got a panel user interface. Handling small data is the one we're at. If you double click any of these, you'll open them as well. But this is the one we want right now. Okay, you can go ahead and hide that. I'm going to make my screen a little, my font a little larger. I'm going to try that again. No, this one. There we go. Okay. And there it is. That's your notebook. So rather than write raw Python into a file, then invoke Python to run the code to see the results in a console, you get to do it here. Okay. You can have all kinds of code. Each of these things is a cell. That's one cell. Here's another one. And there's a third one. Okay. These cells here that are highlighted code blocks are your Python code. Okay, and cells like this one below it, if I double click it, this is just text. Okay, this is markdown text. You can learn about markdown another time, but you want to type out notes to yourself, just go ahead and type them. You can learn the markdown syntax later. Okay, so here I am in a cell and I'm editing away. Okay, if I hold down the shift key and I press enter, we execute the code in only this cell. Again, right below it, you see hello worlds. I know some of you have already used R notebooks and you're familiar with this layout. Just in case we're not, I want to cover the basics, okay? And this is super handy because if I decide to say that's not right, the canonical thing is hello world and there's no exclamation mark, I'm going to edit that, shift, enter, and I run it again, okay? And that's handy. There are other controls. Some of these run this cell and everything below. The two triangles restarts the server in the background, well, actually the Python part of it, and then runs all the thing. So I want to avoid using these. I want to run these one at a time, and I'd like you to do the same, okay? And whenever you're doing this, feel free to type your own code, okay? The only way you're going to learn how to do this any better is to actually type things yourself. What if I print a number and do shift enter? Okay, I get that number. What if I make some quotes and type in a string instead? Okay, shift enter. You know, you can see right away that we're getting somewhere. Okay, print can accept a variable which contains a string, or you can just put the thing, the literal expression, in this case string, in there. Or if you want to float, 1.0001, whatever, print will print and print and print and print. Okay, and you can separate expressions within the print statement, and you know, you'll get a kind of concatenation happening. Okay, so there's your very basics. Okay, and you can try typing these out. Can you do that now? I don't know how this is going to work on Zoom. It's better if you guys are all around the table and we're together, then I can see your fingers moving. Let me know in the chat or open your mic out. Go through these. Okay. Sorry, one tip. If you're in a cell and you hold down the control key and press minus, okay, you can get, that's not right. Oh, it's control. So this is a hotkey. I was using a different version of this before. Is there a way of doing it? There's a way of splitting. Oh, there it is, split cell. So it's control shift minus. Usually there's a button here that allows you to do it. I'm not seeing it. If anyone knows how to do this, please tell me. Control shift minus. There, now I get a brand new cell and I can do things like foo equals. Now, foo equals, don't forget, we set foo already, okay? Foo still exists, okay? That cell doesn't live in isolation. It the variables you declare here live within the whole notebook. So I can just type foo on its own. Oh, this is, I think this is Markdown. Oh my goodness, this was easier in VS Code. There, Markdown code, okay? Okay, anyone having trouble, please let me know right away, okay? Right, there we go. Foo is still set to the value hello world because we never changed it. There it is. Okay, now I can go ahead and say foo is 1, 2, whatever. Okay, shift enter. Shift enter won't return anything. Instead, the way this works is that Python will always return the last thing that was returned. Assigning a variable doesn't cause any value to come back. You have to put it again on its own like that. Okay, and now you'll see it. Okay, so go ahead and type all these out. You can say, do it again. Foo is, there's a list now, 1, 3, 6. Okay. Oh, again, and our foo has to be a line on its own. Oh, what a mess. Okay, and what are we going to get here? We're going to get the list. Okay, how do we know it's a list? You can use this one here, type. What is foo? You're asking a question here, in a way. And this will return the type of foo, okay, which is a list. And we're happy with that. Great. Okay, now on to more complicated things. Using Python as a calculator is pretty handy. Let's say, here's our problem statement. Okay, think of the abstraction again. 1 plus 3 times 4 divided by 2. You know, it's going to look like that, right? And you know, because you guys are all smart, you all went through high school, right? That 4 over 2 is going to be computed first, not the plus. That comes later. That'll happen first. Then the 3 times 2 is going to happen, giving us 6. And then it's 1 plus 6. The result will be 7. Okay. And the way you express that in Python is here. 1 plus 3 times 4 slash 2. The times is represented by the star and divide is represented by the slash because we don't have those characters on the keyboard. Okay, and the only reason we're doing this, really silly, is that you don't have to do things like this. You can, you know what, I should copy that first. Okay, what's the result? It's 7, okay? You don't have to enclose things. We'll need another one for the time, just to make sure the order of operations is right. Yeah, you no need to do that, okay? Headmass is in effect, okay? And it's acceptable to use Python just like that. Okay, this will give you exactly the same result, okay? So you already know that. So as long as you remember that times is a star and divide is a slash, you already know how to use Python as a calculator, okay? So the exercise we have is to work on this. I'm just checking the time here. I think we are now officially over. Okay, so we're going to continue this on the break. Okay, seconds per day. How many seconds are there in an entire day? Okay, I know you can figure it out in your head, but don't. Let Python do it for you and figure out how to do that. Okay, so that's all we're going to do for the handling small data. We're going to go back now to our slide deck, which doesn't take full screen anymore. There we go. We'll nudge it up there. Okay, so I hope that gave you a little bit of an introduction. Think of a variable as a cup. Okay, it's a great analogy, and we'll use the analogy again a little bit later.